Okay, so today we're going to deal with inequalities involving two triangles this time. Before we were only talking about one triangle, right? Today we're going to talk about two. All right, so let's do this proof together. And the reason I'm doing it with you is because this proof's a little bit challenging, okay? It's not that we can't do it, but it is a little bit more challenging. So let's do it together. All right, so first let's write out all of our given statements. YZ is congruent with XZ, which is right here. YZ and XZ. Z is the midpoint of AC. That's a clue, right? What's next? The measure of angle CZY is greater than the measure of angle AZX. Let's label that. So CZY is CZY right here. So this angle is greater than that angle. That's what that's saying. What else? What am I missing? And BY is congruent with BX. Here's BY, here's BX. What do you mean, how is it possible? Good question. Just because the angle's different, I didn't say the whole side is the same. I said just from here to here is the same as here. Where? Here? Why couldn't they be? We're talking about this angle. This angle only has something to do with this triangle here and this triangle here. You see it? We're going to talk about it right now, Devin, and then it's going to become clear, okay? That's why I'm doing this one. All right, so I need to write that that's my given. Okay, so looking back at this, what was the first thing that jumps out at you? Midpoint, exactly. What about the midpoint? What can we say? Good. You guys are all talking at the same time. AZ is congruent with ZC. AZ is congruent with ZC. Because of, good job, midpoint theorem. What else jumps out at you? Can you? You could. We don't need to. They are congruent, but we don't need to. But good job. What else? XZ and ZY, we already said that. What angle? Angle A and angle C? We already said that, but we don't need to say that. What else? What have we been talking about? It's not, though. This angle is smaller than this angle. What did we say about when we have angles that are larger or smaller than each other? The opposite sides, right? So if this angle is larger than this angle, then this side is larger than that side. So that's what you were talking about, right, Devin? We're getting there. That's where we're going. No, you can't. Because you'll see why. Okay? That's why I'm doing this one with you. But you're seeing exactly which way we're going. Okay? So I need to say that YC is larger or greater than...
Wouldn't it be YC?
No, just right here. Because this is the angle opposite to this side. So YC is larger than XA.
Put the line above YC.
Thank you. And I can say that because, let's write it, if one angle is greater than another, good, then the opposite side is greater than the other. Okay? Kind of a condensed version of it, right? Okay, so from here, we need to state, right here we have by is congruent with bx. By is congruent with bx, okay? But I'm going to manipulate these measures, and when I manipulate measures, do I use measure when I have congruent?
No.
I use measures when I have equal. So we need to say that by is equal to bx. How do we say that? Definition of congruence. No, because we're talking about a side. We only talk about the measure when it's the angle. This, just right here, this statement says the measure of by is equal to the measure of bx. All right, so now that I know that bx is equal to by, now I'm going to add them. So by plus yc is greater than bx plus xa. What property tells me that? This one's a little bit...
Addition power.
Okay. Segment addition is not yet, but you'd think it would be, right? It's addition po. Good job, James. I added something to both sides, right? And I actually added the same thing to both sides, didn't I? I had right here that YC is greater than XA. Isn't this YC and XA? And I added to both sides BY and BX, correct? Doesn't BY equal BX? So can't I add it to both sides because it's the same measure? Correct? Okay, I know that it's a little bit long, but are you all following me so far? Okay. Now what should I say? BC equals what? BY plus YC. We actually have to add them together, correct? BC is equal to BY plus YC, and, or AB is equal to what? BX plus XA. So Megan, now what's that one? Segment addition. And now, when we come back. bathroom break. So now that I have that BC is equal to this and the AB is equal to this, now what can I say? Good job. BC is greater than AB because of substitution. Good job. How did you do that? Where'd you get that from? Does everybody see this? This right here, we already proved that this is greater than this. Correct? This whole thing, when they're added, this side is bigger than this side. So since I did that, once I came to this step and actually named that this segment right here, when you add them, becomes the whole thing, now I can say that BC is greater than AB because I used substitution. I substituted BC in for this and AB in for that. Clear? Okay, let's move on. So let's talk about side, angle, side inequality theorem and side, side, side inequality theorem. A little bit of writing here. This is what I was talking about. Okay. Ready? So, if two sides of one triangle are congruent to two sides of another triangle, then we can say, so is that clear here? I've got this side and this side, and this side. Got it so far? If the included angle of the first triangle is, what do you think I'm going to say? Not congruent, not equal, greater. Greater, so, and which one is the included angle? F. If F is greater than C, right, so let's write that. The included angle of the first triangle is greater than the included angle of the second triangle. Then we can say that if the included angle of the first triangle is greater than the included angle of the second triangle, then the third side of the first triangle is greater than the third side of the second triangle. I told you it was long. No. Now we can just say this. SAS inequality. Because SAS is side angle side, right? This is side angle side inequality. So it's stating that if this angle is bigger than this angle, then this side is larger than this side. Which we already knew before, right? Okay, so what do you think side, side, side inequality theorem is going to be? What? All about the sides. right? So let's write this one. Two sides of one triangle are congruent to two sides of another triangle if the third side of the first triangle is what? Greater than the third side of another, then the included angle of the first is what? No. Greater than the included angle of the second. The converse, right? This one says if these sides are congruent and I have one angle that's bigger than another, then the third side is bigger than the third side. The other one says if I have two sides that are congruent and the side is bigger than the other side, then I know that the angle is bigger than the other angle. See how they're the same thing? One, you know that the side is bigger, so you can prove the angles. The other one, you know the angle is bigger, so you can prove the side. See how they're different? How you guys doing? Tired? Okay. So the work part of this is not hard, so let's get to it. Ready, Devin? Almost? Okay, let's get going. I can come back to it. Okay, so write an inequality using the information in the figure. So we're going to compare the measure of QSR. So here is QSR, this angle right here, and the measure of QSP, which is QSP, this angle right here. So if I'm comparing these, I'm going to say, and you don't have to write this for all of your homework, okay? In triangle QSR and triangle QSP, we know, what do we know? Let's talk about all the way around this triangle, these two triangles. So what can we say, Devin, about, this triangle and this triangle? Can you see it? What? Okay, let's end there. Let's start with what is congruent. Can anybody see what's congruent? PS is congruent with what? SR. What else is congruent? SQ is congruent with SQ by reflexive. And QR is what? What about QR? It's greater than what? PQ. So by which theorem am I going to use? I know that this is congruent, I know that this is congruent, and I know that this angle, this side is larger than this side. So which one am I going to use? So by side, 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 inequality theorem, side, 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 inequality theorem, I can say that the measure of angle QSR is what? Greater than the measure of angle QSP. Pretty easy, right? It's all right there in front of you. I didn't have to write all of this, but I did because if you were doing a proof, that's what you would do, right? You would say, I know that this side is congruent with this side because of reflexive. I know that this side is congruent with this side because they say so. I know that this side's larger than that side, so I can prove that this angle must be larger than this angle. This angle is larger than that angle. So it says find the range of values containing x. So this is where the algebra comes in. So find the range. I have the fact, Devin, turn around please. I know that the measure of this angle is 5x minus 14, and the measure of this angle is 46. So how could I write an inequality for that statement there? Good. 5x minus 14. This one is bigger than this one? It's less than. It must be less than, right, Devin? It's got to be less than 46. So let's solve for that. If I add 14 to both sides, what do I get?
Okay, 5x less than.
Good. And so if 5 x's are less than 60, then 1x is less than 12. I don't have to plug it in. But we're trying to find a range. So that's the top of the range, right? X can't be 12, because if x is 12 and I plug it back in, it'll be 46. And they can't be the same size, right? So it has to be less than 12. So x has to be smaller than 12, but x has to also be greater than, this is the harder one. No.
Greater than 14.
It's tricky.
Greater than
Good job. Good job. 5x minus 14. This angle right here has to be larger than 0. Because if it was 0, it wouldn't be an angle, right? So solve for that. 5x is greater than 14, and I already worked this one out for you. X has to be larger than 2.8. So our answer is x has to be between 12 and 2.8. So if it was larger than 12, it would be bigger than 46, and if it was smaller than 2.8, it would be 0. That's the range. We're done.